In this video, we are going to discuss what an initial value problem is. So far we have solved a very simple differential equation, and we got C's, right? We had a C1 and we had a C2 in that last video, and we get these when we're working these problems out anyway. What we're going to use from here is we're going to use what's called an initial condition. These are going to be given to us, and what this means, if we take a look, actually, look at example 2 down here at the bottom. We have this thing and this thing. These are what are called initial conditions because we plugged in a 0 and it tells us what we got. It just tells us two values here based on our actual function. Remember, what we're trying to find is that function that satisfies this DE when I'm solving a differential equation. The IVP, which is an initial value problem, that's what we're going to start calling them IVPs. We're going to see these for the rest of the semester now. All it is it allows us to solve for the C's to get a specific solution. So once you get an answer, and then there's a line here, the solution will not contain constants. We're actually going to solve for those. Once we solve for a constant, then that solution is what's called a particular solution, right? Before that, it was called a general solution, right? C1, C2 could be any C's that we really wanted to pick. But once we have our initial conditions, it's going to make us narrow down our problem instead of having a general solution with a lot of answers down to one particular solution or a single solution. So let's give this a shot. So we're going to practice our solving a simple DE. So we'll do that first, and then we'll work with our initial conditions. Okay, so I have y double prime equals this mess here. To find y single prime, I would take the integral of y double prime with respect to x. All right, so I'm going to plug all that in. Okay, this is a u sub. I'm not going to show all the details to it, but u here would be 2x, so du would be 2 dx, and we would want to put the 2 on the other side, and that's what we'd be replacing for the sign. I do these pretty quickly. What I like to do for this is I like to actually just, because I know it's going to be a cosine, so what I like to do is do cosine 2x, and then I just think about what's going to happen if I take the derivative. Okay, if I take the derivative of cosine, I get negative sign. That's good. So the negative is taken care of. But if I take a derivative of this cosine, so cosine's negative sign, then I take the derivative of 2x, I get a 2. So I need that to cancel out. So I got a 1/2. You could use your u sub over here and go through that whole process the way that you have learned. We do these a lot, so you may want to get quick at it. Okay, so minus here, we got x cubed over 3, and then we have a c1. This is y prime. Okay, so now this is where this stuff comes in, our initial condition. So using, right, this says, for my derivative, if x is 0, y is 3. So we just plug this in. All right, I'm going to do it right here. So I got 3 equals 1/2 cosine of, I'm just plugging in 0, minus 0 to the third power over 3 plus c1. Okay, I'm working this out. Cosine of 0, hopefully you know your trig identities, or sorry, your trig values. Cosine of 0 is 1, so I got 1/2. Then I got minus 0, it's gone, plus c1. Now solving for c1, right, we get 5 over 2. So I know that y prime is equal to 1/2 cosine 2x minus x cubed over 3 plus 5 over 2. All right, but that's not what they wanted. They didn't want y prime, they wanted y. So I got to keep going. So if I want y, that is the integral of y prime dx. So plug all this in. All right. Then I take that derivative. So y equals. All right, so I like working backwards on this. Okay, sine would give me a positive cosine. That's good. But I'm going to have a 2x. That can't change. So sine 2x gets me cosine 2x, but the I'm going to have a half out there already because the half that exists, and then the derivative of 2 is 2, so this needs to cancel. I'm going to have a fourth. So all I do now is once I have that, I check my derivative. Derivative of sine is cosine 2x. Okay, that's good. Derivative of 2x is 2. 2 times 1/4 is 1/2. If you need to use u sub, please do. That is going to happen a whole lot. So find a quick way. Right, I got x to the fourth. So I can't draw a straight line to save my life. X to the fourth divided by our 4, we get 12. And then plus, we got 5 over 2, so this is 5 over 2x plus c2. All right, let me make some room here. Sorry, you won't have room in your notes. Just maybe write a little smaller or do what you got to do. Just the white paper. All right, so I'm still working. Now, we have our initial condition. It was y of 0 equals 0. Now I'm using the one that's just y, not y prime, because we have y now. Plugging all this in, I got 0 for y equals 1/4 sine times 0, 2 times 0, minus 0 to the fourth over 12, plus 5 over 2 times 0 plus c2. All right, sine of 0, if you remember, is 0, so c2 is equal to 0. Right, therefore, we're done. We have y. Y is equal to 1/4 sine of 2x minus x to the fourth over 12 plus 5 over 2. Sorry for my crappy 5 there, plus x. And then it's a 0, so I'm just going to leave it off. So there is my solution. Try to make a box there. There we go.